Welcome to Windows Presentation Foundation, Data Binding with WPF. In this screencast, I'm going to show you a quick example of how data binding can be used to improve your WPF applications. Data binding is the process of creating a connection between an application's data and its user interface. The benefit of having this connection is that if the data or the user interface changes, its counterpart changes as well. For instance, if you're showing a counter in the user interface, you want the UI to be updated if the actual counter data changes. If an application user is editing some business information by filling out a form, you would want the underlying data to reflect the changes right away. In data binding, there's a binding source and a binding target. The binding source is going to represent the data itself, stored in any number of ways by the client. The target typically is represented by some sort of user interface. This could be a text box, checkbox, you name it, some control typically. Despite the names, the binding source is not always the source of the change. If you have two-way data binding in which information flows in both directions, a change to the user interface, or target, will affect the source. A key part of WPF support for data binding are data templates. Simply put, data templates allow you to easily control how a business object is displayed to the user interface when it is data bound. The template can be defined inline, or if you want to reuse it across multiple controls, as an application resource. The easiest way to understand data binding is by example, so let's take a quick look at what data binding looks like in a simple WPF application. You'll see that I already have a WPF application created, and the basic UI framework has been created. Really not much more than a simple grid with 2 rows. There's no code behind yet, and I actually have a class called contact, and that's going to figure into the demo pretty heavily because this is going to represent our data object. So a contact represents a person who has a name, a list of phone numbers, a list of email addresses, and so forth. So I want to create a list that displays a number of contacts. So the first thing I'm going to do is I'm going to go over and I'm going to create a place to put them, and that's going to be a simple list box. We'll call it contacts list box. And I'm also going to want to load or populate that when the window loads. So I'm going to create an event handler for loaded for the window. And now I can navigate to that. And at this point, I could either directly populate it or take another approach, which is preferred in this case simply because it may take some time to get contacts. For instance, maybe I'm doing a database call to a remote database or using a web service. So anything that might take some time, it's better to do in the background whenever you're dealing with a UI-driven application. We don't want to freeze the user interface while our code is being, or our data is being retrieved. So in this case, I'm going to use a background worker, and I'll just define event handlers for run worker completed. Let it automatically generate that for me and do work. And then the last line of our loaded event handler is just simply to call run worker async to kick off that thread. So what will happen is our window will get created, and once it's loaded, it'll kick off a background thread managed by this background worker, and that background thread will go out and populate the data. Speaking of the data, let's create a place to put it. So I'm going to create a list of type contact, and we'll call this simply contacts. And then in the do work is where I want to populate that data object. So all I do is say contacts equals data supplier dot instance dot get contacts. Now I'm not showing data supplier because it really doesn't matter how it gets the data. It could be a database, it could be a web service, it could be an XML file, it could be a flat file, it could be any number of things. They could just be objects in memory. It doesn't matter because what I really care about is the fact that it's retrieved this list of type contacts. Okay, so that's the call that might take some time, which is why it's in the do work event handler. And then once it's done, then we can bind it to the UI because we don't want to do any UI activities within do work, because it's going to be on a separate thread. So that gets less than ideal. In fact, it will cause a lot of errors that way. So what we're going to do once it's finished working is we're going to simply data bind context list box dot items source is equal to contacts. Note that I could have specified item source directly in the XAML, but that would assume that either the data is ready to go, or it's not going to. It can reliably not take very long in order to not slow down the user interface. I'm also below the list box going to add a grid that contains a text block, just simply specifying that loading contacts is occurring. That way, this appears by default, and then after we've done the data binding, then we set the loading grid visibility to visibility collapsed, in effect making it disappear and allowing us to see the data bound list. So let's go ahead and see what we've got so far. Again, all the code behind deals with primarily with getting the data, and then doing this with one line of code here does the data binding. And then the XAML code simply has a list box with a name. So let's see what happens. When we run the application, we get 7 entries in the list box for databinding demo.contact. Well, it's not terribly useful, but let's try to understand why that happened. In this case, we haven't specified anything about how we want the data to be displayed in the list box. And so the list box is going to use its default behavior, which is simply to display a text block indicating, or that's populated with the toString method of the object at hand. Well, our toString method is just the default one that is inherited from system.object, which is going to display the namespace and the class. So that's why we get that. All we have to do is override toString, and instead of returning the namespace and class name, we return the name of the person, which is exposed by the name property. So with that simple change, we try our application again, and this time around we get actual names. So more useful, and now we've got names populated in the list box, but still not very attractive, and certainly doesn't show the power of data binding, especially with WPF, where you have such rich opportunities in user interface. So what I'm going to do is I'm going to create a data template, and I'm going to switch over to the XAML, and here as a child of the grid I'm going to define some resources, and in fact the resource that I'm going to define is a data template, and we'll give it a key. Everything in a resource dictionary must have a key, and our key is going to be contacts template. And within the data template, you can supply one child as the user interface. And so oftentimes, or in fact most of the time, you're going to want to use a control that is a container as well. So for instance, you wouldn't want to simply use a text block, because then that's all that it could contain, as opposed to if you used a grid or a canvas or a stack panel, then you could display multiple components. So just for the sake of argument, let's say that we should always use something like a grid or a container, and then in there we can define a text block. Well, let's say I said that text equals somebody, and then I move down to the list box and I specify that I want the item template for the list box to be equal to the dynamic resource called contacts template, which I've defined up above. Let's go ahead and try that. So we get somebody 7 times. So in a sense, we've regressed from our previous
previous run, because now we're not even showing the names anymore, but that's because we've hard-coded the text value. Well, we don't have to hard-code it. We can actually use a syntax that allows us to bind to a property of the object. So in this case, we want to do a binding to the name property of the object. So by putting that into the text property of text block, we try our application again, and now we're back to where we were before. Well, just getting back to where we were before is not really the point. The point is we'd like to be able to really fully take advantage of WPF. To do that, I'm going to replace this text block with a lot of XAML. And to save time, I'm pasting in the XAML, but let's just talk about it a little bit. The data template is the same and the grid is the same, but now there's two columns. There's a border in the left column that contains an image brush, and that image brush is using that same binding syntax, although this time it's binding to photo. Well, photo is a property of the contact class of type image source. So that allows us to bind directly to the image and display the picture of the contact. We're also using the same binding syntax as before to get the name. And then we want to get the email address or phone number. Well, in contact, the email address and the phone number are actually not just single properties, but lists of properties. Well, we can deal with that too in the binding syntax. This is a rather rudimentary way of dealing with it, but we can actually reference the first instance of email addresses. And then once we've gotten that object, we can use the dot notation to further get to properties. So we can get, using the same object here, we can get to the label property, the email address property, and then for the first instance of phone numbers, we can get to its label and number properties. So simply by making this change, by adding that XAML code into the data template, we can then get a much more attractive user interface that displays pictures along with phone numbers, and we can fully control the WPF aspects in terms of font look and feel. So it's still a list box, and it'll behave just like a list box. But now we can have full control over what the items look like. All right, so one more thing before we wrap up, and I'd like to talk about the actual binding portion, and that is when something changes in the object itself, how do we make sure that then the UI is updated? And that's a big part of the data binding story. I'm going to add a stack panel down after the list box. And you'll note that this includes a text box and a button. And when somebody clicks the button, what we want to do is update the underlying contact. So we'll use contacts listbox dot selected item to retrieve the currently selected item. We'll check to make sure that it is not null if we're going to be going after it. And then we'll simply specify that we want to retrieve the contact as a contact, and then update the name to be equal to whatever's in the text box. So note, and this is a key part of what I'm doing here, that we are modifying the name of the contact. We're not modifying the text block. We're not updating the UI. We're updating the underlying data. So the contact is what's being modified here. So let's see what we can see. If we try this now, we should be able to see a text box and a button. We can select a person, and we can type in a new name, and we click update, and nothing happens. Well, the reason nothing happens is because we haven't set it up properly to allow for the object to notify the UI when it's been changed. So the UI is okay because most of the controls implement the dependency property that they need to in order for data binding to work. What we haven't done is we haven't made the requisite change to our contact class. And that change is to make sure that this implements I notify property changed. I can right click and select implement interface, and that will take care of a portion of the code for me. Now I need to define a method here. It'll be called on property changed, and we'll define a new property changed event handler, and we should always check for null in case no one is listening. Then we don't want to call this because we'll get a null pointer exception. So now we have a method that we're going to use, and then where do we use that method? We want to fire that anytime somebody changes the object. Now we'd probably want to go through and make it so that anytime somebody changes any aspect of it, but that would take a little while. So just in the interest of doing a demo, I'm going to create a backing name variable, and instead of using the automatic properties here, I'll use the old approach. So essentially have the same thing, only now because I have code for the setter, I can actually call on property changed, indicate the name that's changed. So now my class is notifying anybody who cares, which in this case is the dependency property in the user interface, that something has changed. And so just by making that change to the contact class, and notice I didn't make any change to anything else. I didn't have to register for an event handler somewhere else. I didn't have to modify the UI code in XAML or XAML.cs. All I had to change was the contact class to implement iNotify property changed. And now when I execute this, I can select a something in the list box, update the name, and when I click update, then notice that the UI reflects that immediately, right? Even though the only thing I actually set was the name property of the contact, so the data object was being modified, and all magically through data binding, the UI was updated. Thanks very much for your time as always, and hope you learned a little bit about data binding in this session. Thanks.